Welcome to Game Theoretic Solution Concepts with Spreadsheets. My name is Borsha and I will be the instructor for this course. Game theory is a popular discipline with myriad applications in areas like economics, computer science, strategy, evolutionary biology, etc. From the problems of demand and supply, government policies, military tactics, supply chain optimization, to artificial intelligence, all can be analyzed with the frameworks broadly classified under game theory. In this guided project, we are going to focus on two major decision rules, the maximum strategy and the minimax strategy, as well as the solution concept of Nash equilibrium. I will teach you how to solve the decision rules manually and utilizing a pre-made template in a spreadsheet program. For this project, we will be using the Google Sheets. You can try the same in another spreadsheet software. Some formatting tweaks might be required there. Before we begin, let me familiarize you with the RIME platform. On your right-hand side, you can see my screen, and on your left, you have your own system so that you can follow up the steps that I show you on my screen. You can change the size of the windows by dragging the edges, and you can readjust the system preferences from the settings panel between the two windows. Feel free to pause the videos whenever needed and work out the exercises on your own. For this project, you would need to log into your Google account to access the template spreadsheet. Simpler games, a two-player game, each with two strategies, can be represented in a 2 by 2 matrix, which could be solved manually, but with increasing complexity. For example, each player having more than 4 strategies, the need for technology arises. So we will use a spreadsheet solution. You can see the spreadsheet open in front of you. I would request you to sign into your Google account. To make your own copy, please click on File, then go to Make a Copy. You can rename it if you want, and then click OK. There, you have your own copy. You can see the introduction page. It will give you an overview of the 8 tasks we are going to cover in this project. In Task 1, we will have a brief introduction and how to use the matrix notation to express payoff. From Task 2 onwards, we will discuss the decision rules and the solution concept, and each will be followed by the two templates to solve for the higher order payoff matrices. In Tasks 2 and 3, we will work on maximum strategy. In Task 4 and 5, a case of two players, one having a minimax strategy and another having a maximum strategy, will be discussed. And in the final segment, we will talk about Nash equilibrium and will see two classical problems, namely the prisoner's dilemma and the hawk-dove game. At the end of this project, you can download the empty and the completed copies of the spreadsheet to take with you and practice on your own. That's the brief introduction of the project. Next, we will proceed with the matrix notation. Please click on the second sheet named as Matrix Representation. You can see at the bottom of your screen. Now a new sheet has opened. On your right, you have a small matrix outlined in blue. We are going to use that as the reference here. The matrix basically represents the payoffs of a two-player game played by player 1 and 2. Payoffs, in essence, is the value associated with possible outcomes of a game. This value differs based on the strategy selected by the players. Here, player 1 has 3 strategies, namely A1, A2, and A3, and player 2 has two strategies, B1 and B2. Therefore, the payoff matrix is of dimension 3 by 2, having 6 combinations. Note that in each cell, the first numerical value denotes the payoff or gain of the row player, which is player 1, and the second numerical value, separated by a comma, is the payoff of column player, that is player 2. It is a rather simple tabular form to visualize the payoffs, but we need some modification to be made when we are using some mathematical operations on it. Now look at the bigger matrix on your left. I have made it with some extra rows and columns to accommodate for more strategies. The template can be made to calculate even higher number of strategies. We can fill this matrix with the values of the smaller matrix as follows. All the odd-numbered columns are reserved for row player, and alternatively, all the even-numbered columns are for the column player. For example, the combination of A1 B1 is 2, 1. So we will fill 2 against A1 in the first column and 1 in the second column. Note that both are under B1. Similarly, we can fill in the rest of the matrix. You can pause the video and try it yourself. Great! I hope you have tried it and have been able to fill up the matrix. You can see my solution here. I have made these two colored matrices. Just to reiterate that the blue matrix shows the columns to be filled for player 1 and the orange matrix is for player 2. In the next task, we will be introduced to the very first decision rule of this project, the maximum strategy.